So here's our initial implementation of the Browse History class. We're using a list to store the list of websites we have visited. And in the main method, we're using this for loop to iterate over this history object. Now let's see how we can implement the iterator pattern and prevent future breaking changes if we change the internals of the Browse History class. So first we add a new class. We change the kind to interface and call it iterator. Here we need three methods: boolean, hasNext, string, current, and void next. Now this interface is not very reusable because the current method is returning a string object. What if tomorrow we want to iterate over a list of users or a list of customers? We don't want to recreate this interface every time we have a new scenario. So in Java, we have this concept called generics, which allow us to create general purpose classes and interfaces. I don't want to get too specific about Java in this course, but let me briefly explain how it works. So we add these angle brackets over here and then type T, that is short for type. So here we're defining a type parameter. With this, we can replace string with T. Now we have a general purpose or generic interface. So when using this interface, we'll supply a value or an argument for this type. So somewhere else in our code, we'll say implements iterator of string. That means the current method will return a string object. Maybe somewhere else we'll type implements iterator of user. So the current method will return a user object. So that's what generics are for. Now let's not worry about that and simply return a string object over here. So here's our interface. Now we go to our Browse History class and create a nested class that implements the iterator interface. Why a nested class? Because this is part of the implementation of the Browse History class. Let me show you what I mean. So as part of this class, we create another class. This is a nested class because it resides inside another class, okay? So we're going to call this list iterator and have it implement the iterator interface. Now we press Alt and Enter to implement the methods. So this list iterator knows how to iterate over a list of URLs. So first of all, we need a reference to a history object. That is the history object we're going to iterate over. So we can add a constructor, public list iterator, and give it a parameter of type browse history. Now we need to create a private field and initialize it using the value of this parameter. So we press Alt and Enter and create field for parameter history. Take a look. So in this class, we have this private field and we're initializing it in the constructor. So this is the history object that this class is going to iterate over. Now, in this class, we're going to have some state. So we should know how many items we have visited so far. To do that, we add another field here, private integer index. Now, in our hasNext method, instead of returning false, we're going to return the value of a Boolean expression like this. Return index less than history. Now, because this list iterator is part of the Browse History class, it can see all the members of this class, even if they are private. So here we have access to the URLs field, and that is the reason I declared this class inside of the Browse History class, okay? So this returns a list of strings. Our list has a method called size. So as long as index is less than the number of items in the history, that means we have more items to visit. Now, to implement the current method, we write history.urls.get. We get the item and the current index. And finally, in the next method, we write index plus plus. This will increment the value of this field by 1. So this is a concrete implementation of the iterator interface. Now, in our Browse History class, we no longer need to expose the list of URLs. We want to keep this private in our class. We don't want others to know if we have a list or an array or a stack or what. Instead, we're going to add a method, public. It returns an iterator object. We don't know what type. We're just programming to an interface. We call it create iterator. And in this method, we'll return a new list iterator object. Now here we need to pass a reference to a history object. That's the history object we want to iterate over. So that is going to be this, the current object. So let's quickly recap. To implement the iterator interface, first we declared this interface. Then we created a concrete implementation of this interface inside our browse history class. This is implementation detail. This is the only part of the application that should know how to iterate over a browse history object. So if we change the internals of this object, this is the only place that we have to modify our code. I will show you how to do that later. And finally, in our browse history class, we added a new method for creating an iterator object. With this, we go back to our main method. We have a breaking change because we removed the getURLs method. We don't want to know about the internals of this object. So instead, we're going to tell the history, hey, give me an iterator. We don't know what type it is because we're programming to an interface. Let's import this interface. Now we say, hey, iterator, as long as you have more items, give me the current item. So iterator.current. This returns a string, which is a URL. We can print it. And finally, we call iterator.next. Let's run our program. So we see the same result as before, and we don't know anything about the internals of the browse history object. We're simply programming to the iterator interface. If tomorrow we change the internal representation of this history object, this code is not going to get affected. And that's what I want you to experiment with as an exercise. So in the browse history class, replace this list with a fixed size array. You will end up with a few breaking changes inside this class, but you will notice that the main method will not get broken. So go ahead and spend 10 minutes on this exercise, then come back see my solution.